sample. Sometimes we'll have the whole population information. We're assuming that our sample is going to be reflective of our population, so we're making judgments about the population based on the sample. And the steps, you're going to state your null and alternate hypothesis. And I stressed Friday, your alternate hypothesis is what I'm looking for. Your null is going to be the one that I'm trying to prove or not prove, reject or not reject. And null means that nothing happens. So I use the example of a weight loss medication. My alternate hypothesis or research hypothesis would be that you lose weight using my medication. The alternate hypothesis would be that either you gained weight or you didn't lose any weight at all. So you have to make sure that your null and your alternate hypothesis cover everything, every possibility. You can't just say either you lost weight or you gained weight. You have to say, what about the people who didn't, nothing happened at all. Then you need to select the level of significance. We've talked about this for chapter 9. Usually that's going to be 95 or 99%. Identify the test statistic. If I'm going to use the F statistic, which will be in future chapters, but if I'm going to use Z or T, and I went through that, and we'll go through that again. Formulate a decision rule, which is my cutoff. I used the examples of using 95%, and we had the 1.96 and 2.53. Those are cutoffs that if I say if it goes past this point, then I'll reject the null. If it doesn't, then I won't. The null hypothesis, just a statement about the population parameter. Nothing happens in the null hypothesis. There's no change, or it's the opposite of what I'm looking for as a researcher. And the alternate hypothesis would be what I'm looking for. I'm trying to get the evidence to prove this. The test statistic we might use would be Z, T, F, or chi-squared, which we're going to get to these last two later. But Z and T is what we're going to use in chapters 10 and 11. And the critical value, again, is that cutoff value. Some things to know about the alternate and research hypothesis. I'm shaking a little bit. The HO is always presumed to be true. The null is always presumed to be true. It's always presumed that your weight loss medication isn't going to work. So that's why you've got to do this experiment to prove that it does. H1 and H2, or H1 and HO, the null and the alternate hypothesis are mutually exclusive. You can't be in both categories. And they're exhaustive, collectively exhaustive. Everything has to be in one of these categories. It has to include everything. And we're not saying that if we do not reject the null that that's true. So if I'm saying we can't say that my medication doesn't work, that doesn't mean that it doesn't work. We're just saying that there's not enough evidence to prove that it does, so we're erring on the side of caution. And that's kind of the confusing part with hypothesis testing. We're not proving either one, we're disproving the null one. And then the equality is always in the null, so I'll always have the equal to, or greater than, not equal to, less than, not equal to, things like that. Or greater than, equal to, sorry. I'll always have this equality sign in the null. And then always have these inequality signs in the alternate hypothesis. So I want to know if a weight loss medication makes you gain weight, if the cholesterol medication helps lower it, if there's no change at all, or if there's just a change either way. Okay, let me get these up here. Examples of symbols that we would use, and you'd know if I gave you something, you'd be able to tell me if that's the null or the alternate hypothesis. Remember, I'm using the inequality signs for either greater than, less than, not equal to. Those are going to be the H1, the alternate hypothesis, and all the rest will be the null. Now, when we have, when we've proven something or not proven something, we make a correct decision, but sometimes everything, it can kind of be on the border, and we can make an error, which is a type 1 and type 2 error, and we'll go through what those mean. This will be on the test, on the in-class test. You'll need to know the difference in these two. And part of the discussions I might ask you about which one's worse. Is it worse that I tell you that my weight loss medication works and it doesn't? Is it worse that I tell you that my blood pressure medication works and it doesn't? Or that it doesn't work and it really does? So which one would be more of an impact in business, depending on the situation I give you? So if my null is true, that means that nothing happened, but then I say I reject it, that's a type 1 error. If my null is false, that means something did happen, and I don't reject my null, then it's a type 2 error. This is an example of one-tailed and two-tailed tests. I gave you the example last time of if I had a weight loss medication, again, then I would care about just losing weight. I don't want to have to prove the gaining weight or not anything happening at all. That's a one-tailed test. I only care about one side happening. Two-tailed might be, I don't know what the results are going to be, I just think there's going to be a change. So I gather all this data on the number of hours that you sleep and the test grade that you make for your final grade. And I don't know if the more hours you sleep, the better grade you'll get. I have no idea. I just want to know if it stays the same or it's not the same. If there's an impact or not an impact. And that would be a two-tailed test. And here are examples of how we write these out. The 3 different ways you can write these. I have there is no change for the null, and that there is a change. I don't know if it's greater or less, but it's bigger. It's something happening, smaller, something happening. This one, greater than or equal to, then the alternate hypothesis would be less than. And the opposite here, you see that all these signs cover everything. And what I'll do, I'll calculate a t-value or a z-value, depending on what I need. And I'm going to compare it to this critical value that I've set up, and you'll be able to make a decision. So, let's go through an example. Jamestown Steel Company manufactures and assembles desks and other office equipment. The weekly production of this particular desk at this plant, normal curve, a mean of 200, standard deviation of 16. Recently, a new production method has been entered, and they are introduced and they've hired new employees. The VP of Manufacturing would like to investigate whether there's been a change in the production. So if I'm looking for the change, do I care if it's more or less? I just care if there's a change. So I know I'm going to be using the equal to and not equal to signs in my hypothesis. So the first step, and on the in-class test, I'm going to say, okay, write the 5 steps hypothesis testing. You don't write it word for word, that's okay, as long as I know what you're talking about. I have some go, I don't know, cutoff point, and I know what they mean. So know what these are, especially in your own words, if it helps you memorize it. So first step, I want to state the null hypothesis and the alternate hypothesis. I always start off with the alternate hypothesis because that's what I'm trying to prove. So I want to prove that there is a change. Either 200 is way more, or it's above 200, or it's less than 200. I don't know what it's going to be. And then the alternate is going to be that there was no change, that it's equal to 200. The next one, I want to select the level of significance. In the problem, it will tell you, and it's almost always going to be 0.01 or 0.05. 0.01 is 99%, 0.05 is 95%. Those are interchangeable terms that we're talking about with the selecting the level of significance. So if you put here 0.01 alpha, or if you put 99% confidence, either one will be fine. I want to select a test statistic, either Z or T. What do you think I should choose? Let me see if it had the number that it picked. It doesn't say. But I do know what my population mean is. So since that's known, it's going to be a Z distribution. They've given you all the information. You don't necessarily need some of the other information. Select this test statistic. I'm going to use the Z distribution because the sample is, or the standard deviation is known. And then I'm just plugging everything into this formula. This is the formula I'm going to use. Formulated decision rule. Now I've told you, and I'll give you this grid in just a second, what the cutoff values will be for at 95 or 99%, and then it'll be either one-tailed or two-tailed. So I'm going to show you that in just a second after we go through this. But I come up with that 2.58 is going to be my cutoff. So if whatever I come up with for my Z, when I fill out this formula and come up with a Z, if it goes past that 2.58, then I'm going to reject the null. And you can see right here, it says in the shaded area in the tails, you reject the null. If it happens before that, anywhere before that, then I don't reject it. Now I'm worried about both sides. That means when I come up with the Z, it could be a negative and it could fall over here on this side. Because again, I don't know if production has slowed down or increased or what it is. So I enter everything in, I calculate, I get 1.55. They didn't tell us there were 50 in the problem. 1.55, if I enter this in, this is just entering into the formula and calculating it. I come up with 1.55. 1.55 is right here. It does not get to that rejection zone. So I do not reject my null. If I do not reject my null, then I'm pretty much saying that my alternate hypothesis is true. The easiest thing for me to do is to go back and go, okay, This one is not true right here. I'm going to mark that one out. And then this one is true. So that means that there is a change, that this new production method is different. I don't know if it's more or less. It just depends on whatever I happen to pick. Most likely it's going to be more. So let's see. Let's get to this one. Actually, I want to give you this first. If you pull out something to write with, so you can put this in your notes. I can remember where I put it. I don't know if you have it available yet. You might have it. But I'm going to show you this cutoff. You do have it available. You're going to have to fill this table in for the in-class test. And I'll expect you to know what these are, at least for the homework problems too. So if I have a one-tailed test and it's at 95%, I know my cutoff is here or here. And it's or because I care about one side or the other. I'm not caring about both sides. It's one-tailed. If it's one-tailed and at 99% or 0.01, it's going to be this either negative 2.33 or 2.33. And then two-tailed, I care about either side. So and is the key word here. And I'm going to have it 95% two-tailed will be 1.96 and negative 1.96. And then 99% it will be negative 2.58 and 2.58. So this is, like I said, this is all I'm going to give you for the homework problems, the 95% or 99%. So this should be able to tell you what the cutoff values are. So back to where we were. Okay, so now let's look at the same problem, and they want to know if, instead of it being this one-tailed test, which was this 2.58, now I want it to be or two-tailed test, I want it to be a one-tailed test now. My one-tailed test changes the cutoff value, that critical value, to the 2.33. So now I want to see, I know that there has not been a change, and that it's at least on this right-hand side. So I'm going to change it to, is it more than 200 or is it the opposite, less than or equal to 200? All I'm doing is changing the question I'm asking. Nothing else in the problem has changed except for the cutoff value question I'm asking. Because when I calculate it, it'll be the exact same thing. So let me get through it. So again, I come up with 1.55. It still doesn't get to that point. But let's say that I came up with 2.5 as my z-value, or 2.4. Then if I did a one-tailed test, I would reject the null. But if I did a two-tailed test, it wouldn't. If I came up with 2.4, I can get to, there we go. 2.4, it wouldn't get to that critical value over here on the one-tailed test. But if I did 2.4 for, or two-tailed test, one-tailed test, it would get over there, it would get to 2.4. So it just depends on what you're asking, if it's one-tailed, two-tailed, and then the level of significance. If my level of significance changed, if it was 95%, then instead of this being 2.58, it would be 1.96, and it would change how close that the cutoff value is. It would change my results, possibly. So, let me get back to this one. To know what a type 1 and type 2 error, type 1 is defined as the probability of rejecting the null when it's actually true. So saying that my weight loss pills work when they actually don't. And then type 2 is the opposite, saying that they don't work but they really do. And part of the discussion I might give you on the test, and definitely for the discussions that we have, which one is worse and why. And there's not a right or wrong answer, but how you justify it. Which one would be worse, to tell you that the blood pressure medication works when it really doesn't, or to tell you it doesn't work when it really does? The p-value is going to be the area under the tail in the curve. And we did problems like this where I'm figuring out what it is in the tail. I can't figure out what it is because it never touches the x-axis. So it goes on to infinity. So I'm subtracting and figuring out what this alpha is going to be. So if I go back to the same problem, I came up with a z-value of 1.55. To figure out what the alpha is going to be, I'm looking in the back of the book at 1.5 and 0.5, and I'm figuring out what that area is going to be until that point, and I subtract it from 0.5. So I'll go through. We're going to see if this still works, since I put in new everything. Okay, so to figure out what the p-value is going to be, you think they would have turned this around while they were at doing all of this. So I have to stand over here. But the 1.55, if I reach my cutoff in this case was 2.33, and because that's at 99%, then I know that 1% is going to be in those tails. It's a one-tailed test. That means 1% is right here. So if I asked you what the p-value would be, and you got 2.33 or above, then this would be my answer. But if I don't get to that cutoff value, then I just need to figure out what this part is. And thinking back to the other chapters, I look what it's going to be at 1.5 and 0.05, and where those intersect, and that's this value. Let's say it comes with 0.4. That would be this value, but I want this value, so I subtract this answer and come up with a different value. So when they ask you for the p-value, it's asking for the area for whatever this you calculated in these tails. And again, if you get something, if I came up with my z-value was 2.9, then I would just say my alpha is less than this. I don't come up with an exact calculation. It's less than the 1% that we're looking at in the tails. Okay, so here's a good illustration if it ever goes up. There we go. So you'll see what I'm talking about. If it doesn't get to that critical value, then I just want to figure out what the area is going to be, the red lines, and that'll tell me what my p-value is. And that's pretty much my percent of rejecting that null. Here are examples. If I come up with a p-value again, if I get to my critical level, to that cutoff point, then I just say that there's evidence at it. But if I have 0.10, then there's some evidence that the null is not true. 0.05, there's strong evidence, and 0.01, you see the higher the significance, or the lower the significance, the alpha, the higher the significance level, the stronger the evidence is that we can prove or reject something. We're not going to worry about proportion right now. Population mean is the same. T statistic is going to be the exact same thing, exact same steps, everything, calculations, except when I come up with that critical value. Remember we looked in the back of the book and we looked up 95% or 98% or whatever it might be, and found out the degrees of freedom. So when I do my z values to figure out my critical value, I have that table that I just gave you. When I do my t critical values, I'm looking in the back, and depending on what it is, this is where, if you remember Friday, I said, oh, just worry about the confidence intervals because it's all we're worrying with. But now with chapters 10 and 11, we're worried about, is it one-tailed or is it two-tailed, and then what's the significance level. So if it's a one-tailed test and it is at 0.01 significance level, this is the column I look in. And then I match it up with the degrees of freedom, which is just n-1. If it's a two-tailed test and it's 0.01, then I move over here to this column. So that's how you'll figure out what those cutoffs would be. This isn't something I'd ask you to memorize for the test. It's just the z-value ones because those are standard. Okay, so I want to start on chapter 11, and then we'll go through any questions you have for chapter 10. And for those who weren't in here, remember chapter 10 is going to be about, I guess it helps if I click that back on, is going to be taking a sample and comparing it to the population. So I take a sample of all of you as statistics students and compare it to all the knowledge, whatever that I have about all statistics students at your same level. That's chapter 10, comparing you to a population. Chapter 11 is going to be comparing two different samples or two different groups, even two different populations. So I have cell phone bill A, cell phone bill B, and I want to see which one is cheaper or if they're pretty much the same. And when I go through an example, it'll be a little bit